So like I said, we're going to take a test over chapter 8 and 9 material. I know we haven't covered all the chapter 9 material yet, but at this stage I have to get the test in, and since I'm at home, and since we're all at home, and I don't have all my technology because I didn't know we were going to be teaching from home today, I just made an adjustment. So here's what I need you to do. From your Google Classroom, go to the classwork tab and click this chapter 8 and 9 exam. I want you to open that one, link up, and from here, make sure you've taken attendance. If you haven't already scanned the QR code listed here, make sure you go ahead and take your attendance. You can take this, hit this link. This will start your exam. There are 3 calculators. I know you have a lot more resources down here you can use if you want. Like this recording is going to be listed here in the test review. Ooh, I need to list it on there. Oh, that is just the test review. I need to list the YouTube. I'll add this on there as we go. YouTube test review videos, and I'll get that link for you. I'll do that right now. Let's go to YouTube. I'll make sure I don't forget this. So this video will be placed on this playlist that I'm about to show you right here. Copy. All right. Link. Okay. So now that's there. All right, what I want you to open up are these 3 calculators here. The plotting polar coordinates and conversions calculator, the polar distance calculator, and the blank. Well, I'll just open up one at a time. So I'll start with plotting polar points. All right, our test review, the actual test is going to be 10 questions. They're made up of 3 different types of problems. The first type of problem you might see is conversion. So this one says find the rectangular coordinates of the point with given polar coordinates. So anytime you're dealing with coordinates, I want you to use the plotting polar coordinates and conversion calculator. So I'm going to open that one up. And I want you to see this is a mixture of a rectangular graph coordinate system. That's where you have a y-axis and an x-axis, as you can see in the bold black vertical and horizontal line. And then you also have the polar axis here. You've probably never seen a graph like this. You might have seen movies with something like radar. Might look very similar. That is what we call the polar coordinate system. So this Desmos calculator shows both. When we convert, what we're doing is we're taking a point, whether it be polar or rectangular, and converting it. This first problem is polar, and the reason I know it's polar is because the second value is an angle. It's in terms of pi. That means radians. And so on my calculator, if you want to make sure you get these correct, you're going to need to make sure you're in the right mode. So this problem, as I'm looking on my polar coordinate system, you see these degrees around. Well, our problem is in terms of pi. So I'm going to hit the settings up here in the top right and choose radians. That will switch this calculator to where it's now in terms of pi. My point that's listed for number 1 has 1,3/2 pi. So what that means is that's polar, because again, that's an angle. So what you'll do is you'll come on to over here on the side, and you'll choose polar, and you'll put in that value. It was 1 and 3 divided by 2 pi. You can just type in pi if you want, or you can hit the keyboard and press the pi button down there near the bottom. Okay, so from here, when I hit that, I see that this purple point is plotted. And what's nice about polar is if they plot polar, you can just click on it and it'll transform it to X and Y rectangular form. So the answer to number 1 is going to be 0, -1. So when I come over here, I find the option that says 0, -1, which happens to be D. And that would be my correct answer for number 1. Okay, let's try number 2. 2 gives us the point 9 pi. Again, this is an angle, which means I'm going to plot it into polar. So I plot 9 comma pi. On my calculator, you type it in as 9 on the R. Pi is the theta. So that's what these values are in polar. Let me go ahead and write that on there. So you have this point is equivalent to R. I'm sorry, like I said, I don't have my writing tools at home, so I'm just having to write with the mouse. It's a little bit harder. It's in the polar form is R comma theta. So R is 1, theta is the 3/2 pi. On this problem, R is 9, pi is the theta. When I put that in the calculator, it plots my point. I need to zoom out just a little bit right here. When you click it, it says the x and y, the rectangular form, is -9, 0. So the answer to number 2 would be B, -9, 0. All right, let's try C. It's 8, 270 degrees. Now notice this is now in degrees. So we need to make an adjustment. On my calculator, we're right now in terms of pi. And so to adjust the degrees, you go back to this wrench in the top right, and you choose degrees. And now we can put in our point. It was 8, 270. So I'm putting 8 for the R, the magnitude. The theta, or the direction, is 270. And so we get this point right here, which is 0, -8. 0, -8. And when I look at my answer choices, that choice is D, 0, -8. So that is part of first section is just converting between rectangular and polar. So on this page, we were given polar coordinates and we converted to rectangular. Now let me show you if we were given rectangular and we needed to convert to polar. So starting here on this next page, sorry, my zoom tool's in the way. Now, this time around, I'm given rectangular. How I know is this does not have a degree symbol and it doesn't have a pi. So this time the 3 points are in rectangular. And we have to figure out which polar equations are correct. So number 1 says the value is 2, -2. So I'm going to come over here and I'm just going to put this 0, 0 to clear it off. This time, since the point is an x and a y, I'm not going to plot it as a polar point. I'm going to plot it as a rectangular point. The value was 2, -2. 2, -2. Now when I plot this, if you click it, it's still going to say 2, -2. It's not going to tell you the answer like the previous form did. But what polar does tell you is, if you zoom in, is you can actually get the answer without clicking it as well by looking at the angle at which it's located. So this is located between 300 and 330. And if you count the circles, that's the R value. So this value, it looks like, so I'm looking at the circle values. This is 1 unit for magnitude, 2 units for magnitude. It's a little bit less than 3 units at somewhere between 300 and 330 degrees. I'm going to guess 315. So when I look at my answer choices, I'm immediately looking for something like 315, which is the answer. I see B says 2 square roots of 2 at 315. So I'm going to test this. I'm going to go to my polar and I'm going to type in 2 square root of 2 at 315 degrees. Now I want to compare the 2 points, and I can flash it here, and you can see these two match up. When I flash these points, you'll see that the graphs, they do overlap. So this right here at this point would be the correct answer. That 2 squares of 2, 315 is a correct point. Now you might be looking at it going, well, there's 2 points. Well, we haven't gotten to that chapter 9. Chapter 9, there's always 4 different ways you can actually list a point. So we could test this and say, all right, does this value actually work at the other point? So is this value also a good answer? -2 square root of 2, 135. And so I can check it. If I make this -2 square root of 2 and this 135 degrees, whoops, I put 134, 135. And once again, you can see that that is a good point. So this time the answer choice would be B. So all that I got off the angle. I saw that the angle was about 315. And as you look through here, well, this does have a 315, but it was with a negative. So that's why I didn't choose that one first. I didn't check it. But B is the correct answer. Okay, now let's try number 5. it gives us this point. Again, you can look at the 0 to determine, does it have a degree? Does it have a radian? No. So this is rectangular. So I'm converting to polar. So I'm going to come over here, and our point is -2, 0. So -2, 0. Okay, and ignore this polar for a second. Okay, so here's the point. It's at -2, 0. Like I said, when you click on it, it's going to show you the x and y. Well, we need to convert it. So what you can do if it's polar is you can look at what angle is it on. It's at 180 degrees, and it's on the circle value of 2. By the way, the reason, I haven't taught you this yet, the reason they call it an r and not a hypotenuse like I usually write is because the r is referring to the radius of the circle. If you look at these as circles, you can see this is on the circle that has a radius that's 2 units long. So that's why they use the letter r. And so it looks like to me this value will be on the second circle at 180 degrees. And you can check it. Second circle, 180 degrees. And sure enough, those points overlap. As I turn off and on the point, you'll see that it is, in fact, highlighting just like that. So the answer would be 2, 180. So here, check your answers for 2, 180. I see a -2, 180. That's not it. I'm looking for +2, 180. Again, the answer is B. As I mentioned earlier, you could check the other point, -2, 0, but that point should also work. Let's see. If we check -2, 0, so I'm going to put -2. So right in here, there's -2, 180. But then if I change this to a 0, we're back in business again. They're overlapping one another. So the answer to this one would be B. Okay, and then number 6. Again, whenever you get a point, what you need to check is that second value. Does it have a degree symbol? Does it have a radian? If so, it's polar. This does not. No degree symbol, no radian pi symbol. So that means it's an x and a y. So we type this in as a rectangular point. 5 squared is 3 and 15. 5. Oh wait, I forgot the square root of 13. 5 squared root of 13. Square root. Was it 13? No, 5 squared root of 3 and 15. That's what it was. 5 squared root of 3. And the y is 15. I don't see the point yet. I'm going to zoom out until I find it. There it is. So if you click it, that is in terms of x and y, which is not the answer. But you can see that it's on the value of 60. And if we wanted to count what circle it's on, this is 15. This is 20. So it'd be 15, 16. It looks like it's a little bit more than 17 circles out there. So the radius is a little bit bigger than 17 at 60 degrees. I look at my answer choices on number 6, and I don't see a little bit more than 17. That's because it's the 10 squared to 3 value, but I do know it's at 60 degrees. So as I'm looking for the one that has a something, I guess that's equivalent to about 17 and some change. It looks like the answer is going to be C, because these don't have the 60 degrees. So we'll test this. 10 squared to 3 and 60. We'll go test this now. What happened here? 10 square root of 3. The angle, and I'll put 58 so you can see it. I turn it on. You can see that there's a point. I put 58 degrees so you can see as I go 59, it gets a little closer. 60 is the actual angle. So how polar graphs is the r value refers to how many circles it is from the origin. And the angle means the angle in standard position. So you go around till it's 60 degrees. So it's the number of circles out and however many degrees, or if it's in radians, how many radians it is from the x-axis. So that's the first set of problems. You will do these 6. Well, actually in the test, it's going to be different amounts. This review has 15 questions. The test actually only has 10. So the first section, though, is just conversion, and you will use this conversion calculator. Do y'all have any questions for me over section 1 of the test?
No.
Okay. Section 2 of the test deals with the distance. Oh, I'm sorry. I'm going out of order. Section 3 has to do with comparing the equations with either a graph or with the equation in the opposite form. So here I'm given a graph and I'm given 4 equations. These are polar equations. So polar deals with r and thetas. And so you just see which one of these matches up. For this, going from the instructions, whenever you're dealing with a full equation, use a blank Desmos graph. This is where it says for comparing graphs and equations. So I'm just going to open up a blank calculator. I'm going to close off the plotting polar. I don't need that anymore. I'm going to close that off. So now I'm just on the blank one. And I'm going to type in the answer choices until I see this picture. So I have r equals 1 plus 3 sine theta. You can just type in theta by typing in T-H-E-T. And as soon as you hit the A, it'll become a theta. So I'll show you this way. It's T-H-E-T-A. If you type that in, it'll pop up. Or you can go to the keyboard, go to symbols, and it's there on the keyboard as well. Okay, so anyways, I graphed the first one. Looks like that's the answer. So I'm going to assume the answer is A here. Actually, you don't have to assume that is the answer. You could move on, but I'll just show you if you typed in the other ones that they won't match up. So for example, D is very similar, except they have a cosine there. So if I want to see this one, I'll just try this graph real quick. R equals 1 plus 3 cosine theta. Oh, I forgot the 3. You can see these graphs are similar. The difference between sine and cosine is that sine, since it's the y component, sine will graph these pictures up and down. Cosine and polar will either graph it to the right or to the left. That's the difference between sine and cosine. It's x and y. So one graphs on the y-axis, the other graphs on the x-axis. And polar, a lot of times you'll have that type of background. But we just leave it here for now. So the answer was A. All right. Along the graphing are going to be these equations where you convert between equations. So for example, 10, this is a rectangular form of the equation. X squared minus y squared equals 4. X squared minus y squared equals 4. It looks like a hyperbola. And so you would graph your answer choices to see which one represents the hyperbola. One thing to note about polar, when you graph polar, is you cannot have a power on. So on this one, I would have to solve it to get rid of the power on the r. I should rephrase. You can't have a power on the r and the graph still graph it on Desmos. So you could graph some of these other ones. For example, cosine squared theta. Was it plus or minus? Minus sine squared theta. Equals 4. And what you're going to find out is if there's a couple rules on Desmos when you're graphing an equation. You can click on it and it'll let you know. If you're using a theta but there's no letter R in there, you're going to have to switch the theta to an X. It's just how it works. It's kind of unfortunate. Never mind, it's still not working. Let me just leave that one out for now. And by process of elimination, that might be the answer, might not. Let me go to the next one. And B says cosine squared minus sine squared equals 4r. And so I'm going to just copy this. This time it's going to equal 4r. And you'll see this will graph. It actually graphs way in here. Looks like kind of like a 4-leaf clover a little bit. But you can see that that answer choice is wrong. B is definitely wrong. B is not the right answer. You can try C. R squared cosine theta equals 4. Now this one's not graphing because what I was saying is you can't have a power on the R. And so this one, you just have to know your algebra rules. So I have R squared times cosine theta equals 4. What I need to do is take the square root. but I would have to divide out the cosine first. So since that r squared is multiplying cosine, on this one, I would have to do a couple of algebra steps. I'll just show you. I would have to have basically a division of cosine. So I first divide out that cosine, and then secondly, I would take the square root. So r would equal square root 4 divided by cos theta. And I think I typed in some, oh, it's a 2 cosine 2 theta. Let me put 2's in all this. I'm going to say that one's supposed to be the answer. Why is it not looking right? It's cosine 2 theta. There we go. So you can see this one overlaps perfectly. And C, so C would be the right answer. Okay, so that was just a couple rules there. When you graph an equation with polar, a couple of rules is r cannot have a power. R cannot be squared or something like that. That cannot happen. You have to have r to 1 power. So this one I had to rewrite it as r equals the square root of 4 divided by cosine 2 theta. That's what I had to do there. I had to use algebra to solve to get r to be 1 power. And so I divided, since it was multiplying here, I divided the cosine 2 theta, and then I took the square root. And so that was my solution there. The other thing, let me show you D real quick. D was r cosine theta equals 4. R, what's that? R cosine 2 theta equals 4. So you can, when you look at this graph, you can have r with another item that's multiplying or dividing, but you can't have it squared. So that's the difference between C and D. Why you had to rearrange D is because you couldn't have that power. I am curious on C here. If I would have just put this as square root r squared cosine 2 theta equals square root of 4 is 2. No, it doesn't work that way. Yeah, you just have to do your algebra sometimes. I'll do one more of these, and then I'm going to show you another equation here. So let's say you had to find y equals 6. I'm just going to refresh this to clear the page. Let me take off the annotations. All right, let's try number 11 here. So we're looking at y equals 6. So I want the graph y equals 6. And the equations they gave me is r equals 6 sine theta. You can see that that is not the right answer. B is r equals 6 cosine theta. This will be very similar, except it'll be graphed to the right. You see that is not the right answer. You have r equals secant theta. R equals, I think it was 6 secant theta. See that vertical line, but it's not the right answer. And then r equals 6 cosecant theta. This is the right answer. So the answer is D. So I know that the previous was a little bit more confusing because you had to solve for r, but a lot of the problems will not be that way. You just graph and check. And I'll show you one other type of graphing problem. I mentioned that there are 3 types of problems. I'm not done with the graphing, so I showed you one that was just to match a picture. So you might have some that's ask you just to match the picture, like number 7. I might have some that ask you to match the equation going from rectangular to polar, and I also might have some where they give you the polar equation and you have to match the rectangular. And again, you would just type these in. So the first one was r equals 5 over 1 plus cosine. 5 over 1 plus cosine theta. So you're looking for this graph, and you just type in your answer choices until you find it. X squared equals 10y minus 25. So that's not it. The second one, y squared equals 25 minus 10x squared equals 25 minus 10x. Oh, got the answer. Answer's B. That graph overlaps. So that's how you use graphing. As you can see, there was that one that was a little bit confusing problem, but overall, they're not going to be so confusing for you. Most of them you just graph straight up. So again, just so you know the rules, the only time you're going to have to make any adjustment is if in the equation, your r is not, if it has a power, then you'd have to solve for it. A was a problem also on this one because it does not have an r at all. But as long as it has an r, just make sure the r doesn't have a power. So just do algebra to get rid of the power. That'll take care of that. Okay, that leaves us just one type of problem left. It's what we call polar distance. If I give you two polar coordinates and I ask you to find the distance between the two, there is a calculator for that. So let me close this one now. Back in the instructions, I recommend 3 calculators. The polar coordinates in conversion, polar distance, and that's what I'm doing here, and the blank one is what we just finished with. So when I open up polar distance, the way polar distance works is you're going to fill in your 2 polar points here and here, and then this will calculate the distance between the two. So this one says there are 2 ships. One is 6 miles at a 10-degree heading, so 6 miles away, so 6 miles from the origin on a 10-degree heading. That means if you look here, that's like 10 degrees off the x-axis, and it's on the 6th circle. So, I shouldn't say that the way that these values are counting. It'd be on the 6th circle. There we go. Now it's on the 6th circle at 10 degrees. The other point is 4 miles away on a 7-degree heading. 4 on a 70. So you can see this point is 4 circles away from the origin, and the angle is just past 60 degrees. It's at 70 degrees. So you're looking for the distance between those two. The answer is 5.29. 5.29, which is C. Right there. And so let's look at the last problem here. The last problem says we're looking for the distance between 2 planes. There are 2 miles away at 18 degrees and 8 miles away at 84 degrees. So 2 and 18. 2 and 18. Oops. 2 and 18. And the other plane is 8 and 84. So there are the 2 points. The blue represents the distance between them, which is 7.4. This will round up 7.42. 7.42, so the answer would be C. So those are the 3 types of questions you might have on this test. It's 10 questions. Do the best you can. Make sure you filled out this attendance link that was on the very start when I started this video. Let me go back over there. Make sure you fill out this attendance link that's here or that's listed on the Google document. But if you don't have any other questions, you can go ahead and take that. You can retake the exam immediately if you don't like your grade. So make sure you're in your Google Classroom, open up the Chapter 8-9 exam, and from there, you can click there to take your exam. And it says here 3 attempts. The truth is you actually have 10 attempts. Do the best you can. There shouldn't be any reason you can't get 100 on this. So unless you have further questions, you can sign off and get to work.